Welcome to the National Weather Center. I'm Andrea Melvin with the Oklahoma Mesonet. Join me as we explore this one-of-a-kind building which houses federal, state, and academic organizations. After decades of planning to bring together all the weather units in Norman, the May 3, 1999 tornado outbreak brought President Clinton to survey the damage. He stated his strong support of creating a National Weather Center. The budget that President Clinton introduced to Congress in 2000 included a line item for the construction of the National Weather Center, $50 million in federal appropriations. The remaining $19 million came from the state of Oklahoma, for a total cost of $69 million. Groundbreaking for the National Weather Center began in November 2002, and the building was officially dedicated September 29, 2006. The collaborative spirit between the National Oceanic and Atmospheric Administration, NOAA, and the University of Oklahoma combines weather research, operations, and education under this one roof. The building spans 244,000 square feet and houses over 550 faculty, scientists, and students. Let's head inside and learn about the NOAA units. We began at NOAA's Storm Prediction Center. The Storm Prediction Center, or SPC, is one of 9 national centers known collectively as the National Centers for Environmental Prediction. Each office has a specific area of responsibility, from aviation to climate to space weather. You are probably familiar with the National Hurricane Center, NHC, in Miami, Florida. While the Hurricane Center deals with any hurricanes that threaten the U.S., the SPC focuses on all severe weather that threatens the 48 contiguous states. SPC meteorologists are responsible for providing hazardous weather forecasts and watches across the continental U.S. Every severe thunderstorm and tornado watch for the contiguous U.S. reported on your local or national news channels originate from this office. The SPC staff work 24 hours a day, 365 days a year, with rotating 8-hour workdays. The operations area itself consists of 5 main workstations, with additional desks reserved for extra staff when needed. At most, during significant severe weather potential, an additional 1 to 2 individuals will be added to the normal staff. The lead forecaster seated beneath the red digital clock is the shift supervisor and makes sure that all SPC products are of high quality. The lead forecaster ultimately decides when and where to issue tornado and severe thunderstorm watches. Let's focus on the clock for a moment. The time shown is not in local time. The time displayed is Greenwich Mean Time, GMT, Zulu, Z, or Universal Coordinated Time, UTC. They all are the same time zone. Forecasters must use UTC time when looking at data or creating text products to prevent confusion. They can be confident that anywhere in the world the data was collected at the exact same moment because everyone is using the same time zone. The 2 desks close to the hallway window are the mesoscale forecasters. A mesoscale forecaster continuously examines areas of the country that either have an environment favorable for severe weather or are already experiencing severe weather. When a mesoscale forecaster determines that a severe thunderstorm or tornado watch should be issued, they notify the lead forecaster. The mesoscale forecaster will outline the area of concern. A conference call between SPC and all of the local weather forecast offices in and around the area of concern will discuss the conditions. The local offices will have the opportunity to add or remove any of their counties from the watch boundaries. Once all of the offices have agreed, the watch graphic and the text are finalized and an expiration time is included before being sent to NOAA weather radios, cell phones, and local media outlets. The desk behind the column is where the outlook forecaster sits. This forecaster looks beyond the short term and assesses the potential for severe weather up to a week from now. For example, the 1, 2, 3-day outlooks and the extended 4 to 8-day outlooks. When you hear your local TV meteorologist talk about tomorrow's slight or marginal risk, The Outlook Forecaster is where this information originated. The Outlook Forecaster combines the daily severe weather climatology with the current weather conditions to determine the probability of severe storms occurring in a particular area. Because severe thunderstorms and tornadoes occur less frequently than rainfall, the percentages used are much smaller. The highest probability used for any kind of severe weather is 60%, while for rainfall it is 100%. The second week of October, the peak values are approximately 0.2%. If the SPC forecaster drew a 15% area, the ratio of the forecast to climatology, 15% divided by 0.2%, yields a value of 75. The SPC forecaster is stating that they believe the risk for tornadoes in that region is more than 75 times greater than climatology. By comparing the forecast probability to climatology, you can more easily understand the magnitude of the risk on a given day. Don't dismiss the lower risk categories. Remember, storms don't know where the risk lines have been drawn and don't know the difference between yellow and magenta. Pay attention and have a plan when there is a convective outlook in effect for your area. Checking the convective outlooks for updates can save you from "we didn't know." In a Ready, Set, Go system, an outlook is your ready phase. These are issued days in advance to give you the opportunity to modify your plans and to think through where you might take shelter if the need arises. A severe thunderstorm watch is issued when there is a forecast of organized convection producing at least 6 total severe weather events. The watch area ranges in size from 20,000 to 40,000 square miles. Watches typically are in effect for 6 to 8 hours. SPC's goal is to issue watches just prior to development with a lead time of 45 minutes for severe thunderstorms and 2 hours before the first tornado forms. Because a watch covers a large area, it is possible for a single tornado to happen without a watch being issued. Once a watch is issued for your area, get set. You should begin making your final preparations to move to your shelter. This isn't the time to clean out your shelter or drive across town. You should have completed those during the ready stage. Remember, SPC is responsible for the big picture view. No matter where you are in the lower 48 states, when a severe thunderstorm or tornado watch is issued, the forecasters here in this room in Norman, Oklahoma, are the people that made it happen. The finer details, the go stage, are the responsibility of the local National Weather Service offices. At the very back is the fire weather forecaster, who provides a national fire weather guidance forecast and delineates areas within the contiguous U.S. where pre-existing dry fuel conditions combined with forecast weather conditions, low relative humidity, high winds, and high temperature during the next 8 days will result in a significant threat for wildfires. Similar to the convective outlooks, fire weather outlooks are also intended to give days' notice of fire risk. SPC forecasters regularly begin their shifts not in front of a computer screen, but instead with paper maps and colored pencils. They still rely on hand analysis of weather maps to help them understand the day's atmosphere. This gives them a sense of which weather station might be experiencing a problem with an instrument or where a gap in data might be located. Then they are ready to look at the different weather models and determine which might be doing the best job modeling the day's environment. Fair warning, don't mess with their pencils. Many of the forecasters have pencil boxes they received as gifts from family that they have had since middle school. Each forecaster has their own procedure for analyzing maps. Some start with a regular pencil, others jump in with colored pencils, but the very brave dive in with colored Sharpies. The TVs in the back display some products that the forecasters are examining. The far left screen is typically water vapor satellite, red indicating drier portions of the atmosphere, and the blue where moisture is currently. The mesoscale and outlook forecasters will be more concerned with the areas of moisture, The second screen from the left displays infrared satellite, which indicates cloud top heights and temperatures. Colder clouds mainly made of ice crystals are higher in the atmosphere, and warmer clouds containing liquid water are closer to the ground. The third screen displays a national radar mosaic, all 159 Doppler weather radars displayed. A single radar only collects data from the radius of about 250 miles. The mosaic images allow us to view what is happening across the U.S. on one map. The far right screen changes to show a close radar view of the area of focus for the day. Historically, forecasters at SPC served as a technical resource for local weather forecast offices. If you ever read an SPC text forecast from the early 1990s, you would find it full of abbreviations, acronyms, and technical terminology. In the age of the internet, all of their graphics and text products became available to the general public. Today, they write in plain language and use fewer acronyms. They even have stopped using all caps. Now that we have had a chance to visit a national center, let's walk a bit down the hallway to our next stop. The Norman Weather Forecast Office, WFO, is part of a network of 122 offices across the country. These offices range from Peachtree City, Georgia to Great Falls, Montana. Each office provides advisories, watches, and warnings for winter storms and floods, as well as other dangerous weather for their respective county warning areas, CWAs. There are 4 WFOs that cover the state of Oklahoma: Amarillo, Norman, Tulsa, and Shreveport. The Norman WFO is staffed 24 hours a day, 365 days a year. The employees work in rotating 8-hour shifts, the day, evening, or midnight shifts. The Norman WFO issues advisories, watches, and warnings for 56 counties, 48 in central, southern, and western Oklahoma, and 8 additional counties in western North Texas, near Wichita Falls. All of the information provided by the WFO is available free online at weather.gov. Typically, you will find 2 to 5 forecasters in this space during normal operations. But in the case of a significant weather event, severe weather, winter weather, flooding, you will see a larger number of forecasters in this space handling a variety of different tasks and assisting in the warning process. Often, forecasters will have to work beyond their normal 8-hour shift. You may encounter intern forecasters, general forecasters, lead forecasters, the staff hydrologists, student volunteers, and individuals from the Warning Decision Training Division observing operations. The monitors in the back of the room are called the Situational Awareness Display System. The display system is useful for many reasons. A variety of weather graphics can be displayed to assist forecasters with the weather monitoring. Current advisories, watches and warnings, radar, satellite, and Mesonet products. A forecaster can move their workstation screen to the display to discuss a particular feature among all the forecasters present. And it is an additional resource for the forecasters when they are issuing a warning to connect them with the external community, such as the broadcast media, storm spotters, emergency managers, police, and fire officials. Often, local news stations will send out their helicopters and storm spotters, which provides a live visual of the storm in progress. This is a good resource for the forecasters, and they can often use it as additional information. Also, in case of a wildfire, train derailment, or other breaking news event, forecasters can quickly contact public safety officials with critical weather information. They can quality check when advisories, watches, warnings are issued, and if the local news networks are experiencing any delays in receiving the information, and that the watch warning areas are correctly displayed on the station's ticker. Local WFOs launch weather balloons twice a day around the country. The Norman office launches from the National Weather Center at 0 GMT Zulu UTC and 12 GMT Zulu UTC. These balloons gather temperature, humidity, pressure, and wind measurements throughout different altitudes of the atmosphere. The balloon, filled with hydrogen, usually bursts at about 100,000 feet. The The instrument packages that are connected to the balloons will then fall back to the ground safely using a parachute system. Only about half of the WFO offices launch balloons daily. That leaves big gaps between reporting stations when collecting upper atmospheric data. This is one of the reasons winter precipitation is so hard to forecast. Researchers and engineers are working hard to find new ways to get more upper air data for forecasters. Some of the other tasks performed at a WFO include fielding phone calls from the public, monitoring social media, using ham radios to communicate with storm spotters, interacting with the media and emergency managers through NWS chat, and making sure their local radars and NOAA weather radio transmitters are in working order. Recording storm reports like location and size of hail, damage from winds or tornadoes are important to verifying any watches or warnings that have been issued. Having local offices means that the forecasters can be experiencing the very weather conditions that they are forecasting. Forecasters must perform these tasks knowing that their families may be at risk. The families of forecasters must be prepared to go, just like any other community member, when a severe thunderstorm or tornado warning is issued by the local WFO office. Every NWS office has backup offices who would take over in the event of an emergency. They routinely practice the transfer of operations to the backup office. If the National Weather Center were threatened or could not function, the NWS office in Tulsa or Fort Worth would take over for the Norman office. The SPC would contact Scott Air Force Base located near St. Louis. The Scott Air Force staff would take over during an evacuation for a period of time no more than 48 hours. Beyond 48 hours, operations would switch to Offutt Air Force Base near Omaha, Nebraska. SPC staff would relocate to Offutt to continue operations until the Norman office was functioning again. I hope you have enjoyed learning about a few of the NOAA groups in the National Weather Center. Thanks for watching. We want to thank the NOAA Weather Partners for supplying the B-roll for this video.